Dear students, during 12th we have seen how to find the maximum and minimum of a function of one variable. In this session, we'll discuss how to find maximum and minimum for a function of two variables. Suppose f is a function of two independent variables x and y. To find maximum and minimum values of f, we have to solve these two equations simultaneously. F by x equal to 0 and f by y equal to 0. Each such point satisfying these two equations is called as a stationary point. For each stationary point, we have to find values of r double square f by double x square, s double square f by double x double y, t double square f upon double y square, and rt minus a square. The criteria is as follows. If at a stationary point rt minus a square is negative, then there is neither maximum nor minimum. Such a point is called as a saddle point. Second, if at a stationary point B rt minus a square is equal to 0, then no conclusion can be drawn and further investigation is needed. Third, if at a point P rt minus a square is greater than 0, then see value of r. If it is also greater than 0, then there exists minimum at that point, and we have to put the values to find f minimum. And finally, if at point P rt minus a square is greater than 0 and r less than 0, then there is maximum at P. And again, we have to find maximum value of the function f. Let us discuss some problems. Find the extreme values of x cube plus y cube minus thrice a xy. A is a finite positive real number. Let f equal to the given function. Let us differentiate f partially with respect to x and y. F by x is equal to 3x square minus 3ay. F by y equal to 3y square minus 3ax. F by x equal to 0 gives x square is equal to ay. F by y equal to 0 gives y square is equal to ay. We have to solve this simultaneously. So squaring this, x to the power 4 is equal to a square y square, put y square is equal to x, and we are getting x to the power 4 equal to a square y square, and that is equal to a cube x. Further solving, x to the power 4 minus a cube x equal to 0, x is taken common, x into x cube minus a cube equal to 0, therefore x equal to 0 and x equal to a. So let us put x equal to 0, then we are getting y equal to 0. Similarly, putting x equal to a, we are getting y is equal to a. So the two stationary points are 0, 0 and a. Let us find values of r, s, t at this. R equal to double square f by double x square, and differentiate double f by double x partially with respect to x, that is 6x. Then s double square f upon double x double y. So differentiate double f by double y partially with respect to x, that is minus 3a, or you can differentiate double f by double x partially with respect to y. Every time you will be getting the same thing. T equal to double square f by double y square, differentiate double f by double y partially with respect to y, that is 6y. And let us have a table now. 0, 0, r is equal to 0, s equal to minus 3a, t equal to 0, rt minus s square is equal to minus 9a square, which is negative. So at 0, 0, there is neither maximum nor minimum. It is a saddle point. Second stationary point a. At this point, r equal to 6a, s equal to minus 3a, t equal to 6a, rt minus a square is equal to 36a square minus 9a square equal to 27a square. And we see that rt minus a square is positive and 6a is also positive, as a is given as greater than 0. So at point a, the function has minimum value. Further, minimum value of the function is faa. So replace x by a, y by a, we are getting a cube plus a cube minus thrice a cube equal to minus a cube. Second problem. Find the extreme values of 3x square minus y square plus x cube. So let us define f equal to given function, differentiating f partially with respect to x and y. Double f by double x equal to 6x plus 3x square. Double f by double y equal to minus 2. Double f by double x equal to 0 gives x into x plus 2 equal to 0. So x equal to 0 and x equal to minus 2, these are the two possible values. Double by double y equal to 0 gives y equal to 0. And thus, straight away, the two stationary points are 0, 0 and minus 2, 0. R. Let us differentiate r partial double by double x partially with respect to x. We are getting 6 plus 6x. Then s equal to double square by double x double y, differentiate double by double partially with respect to x, we are getting 0. And t, differentiate double by double y partially with respect to y, and we are getting it as equal to minus 2. Now at 0, 0 value of r is 6, s is 0, t is minus 2, so rt minus s square is negative quantity. So at 0, 0 there is neither maximum nor minimum, it is a saddle point. Second stationary point, minus 2, 0, r is equal to minus 6, s equal to 0, t equal to minus 2, rt minus s square is plus 12, positive. So let us see value of r which is negative. So at minus 2, 0, the function has maximum value. So f max equal to f of minus 2, 0. So replace x by minus 2, y by 0. And solving, we are getting value of the function as 4. Third problem. Find the extreme values of x into y into a minus x minus y. A is a finite positive real number. Function f, let us simplify. Differentiate f partially with respect to x and y. So double by double x is equal to ay minus 2xy minus y square. Similarly, double by double y will be equal to ax minus x square minus 2xy. Double by double x gives y into a minus 2x minus y equal to 0. And double by double y equal to 0 gives x into a minus x minus 2y equal to 0. Let us solve this simultaneously. So different possibilities are x equal to 0, y equal to 0. Both equations will be 0. Then another possibility, x equal to 0, put x equal to 0 here, y is equal to a. This is another point. Then if we are putting y equal to 0, then x equal to a, this is another combination. And using this part 0 and this part simultaneously, we see that x equal to y and further 3x equal to a, that is x equal to a by 3 and y is also equal to a by 3. These are the four stationary points. Now let us obtain r. Differentiate double f by double x partially with respect to x, and that is equal to minus 2y. S is equal to double square f by double x double y, differentiate double f by double y partially with respect to x, and that is equal to a minus 2x minus 2y. Similarly, t double square f by double y square, differentiate double f by double y partially with respect to y, and that is equal to minus 2x. So this is the table. At 0, 0, r equal to 0, s equal to a, t equal to 0, rt minus s square is negative. So at 0, 0, there is neither maximum nor minimum, it is a saddle point. Second stationary point, x equal to 0, y is equal to a, r is minus 2a, s is minus a, t is equal to 0, rt minus s square negative, and same conclusion. At the third stationary point, r is equal to 0, s is equal to minus a, t equal to minus 2a, rt minus s square negative, the same conclusion. Finally, the stationary point a by 3, a by 3. So r is equal to minus 2a by 3, s is equal to minus a by 3, t equal to minus 2a by 3, rt minus a square is equal to 4 by 9 a square minus 1 by 3 a square. After simplifying, that is a square by 3. This is positive. So let us see value of r. As a is positive, minus 2a by 3 is negative. So at this point, the function has maximum value. And f max equal to f, a by 3, a by 3 equal to. So let us put values a by 3, a by 3, 1 minus a by 3, minus a by 3. So third bracket is also a by 3. So a by 3 whole cube, that is a to the power 3 upon 27. Fourth problem. Find the extreme values of x cube plus 3xy square minus 15x square minus 15y square plus 72x. So this is f differentiate partially with respect to x. We are getting 3x square plus 3y square minus 30x plus minus 0 plus 72. Double f by double y is getting as 6xy minus 30y. So double f by double x equal to 0 gives this expression. Double f by double y gives 6 into x minus 5 into y equal to 0. Let us put x equal to 5 in this equation. Then we are getting y square equal to 1, y is equal to plus 1 minus 1. So the stationary points will be equal to 5 plus 1, 5 minus 1. For another combination, let us put y equal to 0 in this equation and we are getting x square minus 10x plus 24 equal to 0. Solving, we are getting values of x as 4 and 6. So remaining two stationary points are x equal to 4, y equal to 0 and x equal to 6, y is equal to 0. Let us find R, S, T. So here for our differentiate by x partially with respect to x, and that is 6x minus 30. S differentiate by y partially with respect to x, and that is equal to 6y. For T differentiate by y partially with respect to y, and that is 6x minus 30. So let us find the values of RST at each of the stationary points. The first stationary point 5, 1, R is 0, S is 6, T is 0, RT minus S square is minus 36. So at 5, 1, there is neither maximum nor minimum, it is a saddle point. Second point 5 minus 1. So identically here also RT minus S square is negative, so there is neither maximum nor minimum. Third point is 4, 0. R is equal to minus 6, S equal to 0, T equal to minus 6, RT minus S square is positive quantity. So at that point there is maximum. Finally at 6, 0, R is equal to 6, S is 0, T is equal to 6 and RT minus S square is positive quantity. R is also positive, so at stationary point the function has minimum value. Let us find now. As this is the function, f minimum equal to f of 60, and after simplifying it is coming as 108. F max equal to f 40 and maximum value is 112. Next example, find the extreme values of x square plus y square plus 6x plus 12. So let us define f equal to the given function, differentiating partially with respect to x and y. Double f by x is equal to 2x plus 6. Double f by y is equal to 2y. Double f by x equal to 0 gives x equal to minus 3. Double f by y equal to 0 gives y equal to 0. So in this problem there is only one stationary point, and that is p equal to minus 3, 0. Let us find values of r, s, t. So for finding r, differentiate double f by x partially with respect to x, and that is coming as 2. To find s, differentiate double f by y partially with respect to y, x, and that is equal to 0. To find t, differentiate double f by y partially with respect to y, and that is equal to 2. So straight away at the stationary point r equal to 2, s is equal to 0, t equal to 2, rt minus s square is 4 greater than 0 and r is greater than 0. So at this stationary point the function takes minimum value. F minimum is equal to af minus 3, 0, and solving we are getting the answer as equal to 3. Next problem, discuss the maxima and minima of xy plus a cube times 1 upon x plus 1 upon y. This is the function, differentiating partially with respect to x and y. Double f by x will be equal to y minus a cube upon x square. Similarly, double f by y will be x minus a cube upon y square. Double f by x equal to 0 gives x square y equal to a cube. Double f by y equal to 0 gives ax y square is equal to a cube. So solving 3 and 4 simultaneously, we realize that x equal to y is equal to 8. So the only stationary point is here x equal to a and y equal to a. Now r equal to differentiate dy by x partially with respect to x, and that will be equal to 2a cube upon x cube. For s, differentiate dy by y partially with respect to x, it is 1. And for t, differentiate dy by y partially with respect to y, and that will be twice a cube upon y cube. So stationary point A, value of r is equal to 2, value of s is 1, value of t is equal to 2, rt minus s square is 3, which is positive, r is positive, so at point A, the function takes minimum value, and f minimum equal to f equal to, put x equal to a, y equal to a into the function, so a into a plus a cubes times 2a, and that is equal to 3a square is the answer. Next problem. Find the extreme values of sin x plus sin y plus sin of x plus y. So till now we were having algebraic functions, so this time we are having trigonometric function. Theory remains the same. Let the function it be say the given function. Differentiate f partially with respect to x and y. Dy by x is equal to cos x plus 0 plus cos of x plus y. Similarly, dy by y is equal to cos y plus cos of x plus y. Dy by x equal to 0 gives cos of x plus y equal to minus cos x, and dy by y equal to 0 gives us cos of x plus y is equal to minus cos y. So if we are solving these two simultaneously, left hand sides are the same, so right hand side will also be the same, and we are getting x equal to y. Again you can put x equal to y here in this equation, or in these equations we are getting cos of 2x equal to minus cos of x, and minus cos of x is equal to cos of pi minus x. So here 2x is equal to pi minus x, 3x equal to pi, so x equal to pi by 3, and y equal to pi by 3. This is the only stationary point. So let us find values of r, st. R is equal to differentiate dy by x partially with respect to x, that will be minus sin x minus sin of x plus y. S is equal to differentiate dy by y partially with respect to x, that will be minus sin of x plus y. And for t, differentiate dy by y partially with respect to y, and that will be minus sin y minus sin of x plus y. So at this only stationary point P, pi by 3, value of r is equal to minus root 3. S is equal to minus sin 2 pi by 3, and that is minus root 3 by t. At t, again it is coming as minus root 3. Rt minus a square is equal to, so 3 minus 3 by 4, and that is equal to 9 by 4. So Rt minus a square is positive quantity, then the value of r is negative. So at the point P, the function takes maximum value, and if max equal to f pi by 3 sin pi by 3 plus sin pi by 3 plus sin 2 pi by 3, we know sin pi by 3 is root 3 by 2, and sin of 2 pi by 3 means sin of 120, that is sin of 90 plus 30 is equal to plus cos 30, and again it is root 3 by 2, so 3 times root 3 by 2. Let us discuss one more problem. Divide 120 into 3 parts so that the sum of their products taken to any time shall be maximum. Now let the 3 parts be x, y and z with the relation x plus y plus z is equal to 120, and the function, required function in this case is of 3 variables x, y and z. Sum of their products taken to at a time, so it must be x into y plus y into z plus z into x. But we know the theory of how to find maximum minimum of a function of 2 variables. Here we are having a function of 3 variables for the first time. Fortunately we have one relation among x, y, z, so we can eliminate z by putting z is equal to 120 minus x minus y into the function, and after simplification we are getting a new form of the same function, but it is now in terms of only 2 variables x and y, minus x square minus y square minus xy plus 120x plus 120y. So it becomes our routine problem. differentiate f partially with respect to x and y, del by del by x equal to minus 2x minus y plus 120, del by del y equal to minus 2y minus x plus 120, del by del x equal to 0 gives 2x plus y equal to 120, del by del y equal to 0 gives x plus 2y equal to 120. Let us solve simultaneously, so we realize x equal to y and both are equal to 40, thus the only stationary point is 40, 40. Now r, differentiate by x partially with respect to x, it is minus 2. For s, differentiate by y partially with respect to x, that is minus 1. And for t, square by y square, differentiate by y partially with respect to y, that is minus 2. Thus rt minus s square is equal to 4 minus 1, and that is equal to 3, which is positive. Rt minus s square is positive and r is negative, so at the stationary point P, the function attains maximum value. So f max equal to f 40 40 minus 40 square minus 40 square minus 40 into 40 plus 120 times 40 plus 120 times 40, and that is coming as 4800. Or you can do the same function has been like this: x into y plus y into z plus z into x. X is 40, y is 40, so z will also be 40. So 40 into 40, 16003 times, and that is also coming as 4800. So with this we stop here, and in the next discussion we'll be having a session in which we'll be understanding how to find the maximum or minimum point, that is stationary point, for a function of 3 variables. I hope that you are convinced nicely. Thank you.